Hello everybody, it's Mrs. Delacath again. This is the fifth lesson in the signed numbers unit. It's about multiplying and dividing real numbers and also includes an explanation of how to do powers with negative numbers. So let's get started. When you're multiplying and dividing real numbers, the rules are so much easier than when you are adding and subtracting, because whatever the operation is, whether it's multiplying or dividing, that's the actual operation that you do. So the first rule of this is to always do the indicated operation. The second part of the rule helps you determine the sign of your number. So after you perform the indicated operation on the absolute values of the numbers that you are multiplying or dividing, then you decide on the sign of your product or of your quotient. So the rule is, when you're multiplying two numbers together, if the signs are the same, the answer is positive. This is where the little saying, two negatives make a positive, kind of comes into play. So there are a couple of examples right here. We're going to do some other ones in just a second. On the other hand, if the signs are different, meaning if you have one negative and one positive number, then the answer is negative. So the negative trumps the positive in this case. And again, here are some basic examples of those two rules. Okay, so let's go to our examples for this. So just with a couple of integers, let's say that we were going to multiply negative 48 times 10. So just like normally, when you multiply negative 48 times 10, when you multiply 48 times 10, all you have to do is add the 0 onto the 48, because 48 times 1 is 48, and then add the 1 0. I made the pen a little thicker because it's easier to see, I think. So you get 480. Now we're going to figure out the sign. So we have one negative and one invisible positive sign. So since the signs are different, our answer is negative, and that is absolutely how easy it is. Let's say that we were going to do 48 divided by, or negative 48. Divided by 10. So it looks like we're dividing two integers, negative 48 and 10. So we're going to deal with the absolute values here first. Whenever you divide something by 10, you take the decimal point from where it is. So it's invisible in a whole amount in an integer. It's actually is, if I want to make it visible, I would put it right there after the 8. When you divide by 10, you move the decimal point one place to the left. And so 48 divided by 10 is 4.8. Can't see the decimal point very easily. Okay, there we go. And since we have a negative divided by a positive, again, the signs are different, so we're going to use a negative sign. And we'll do one with the same signs in just a second. Okay, so that's the integers example that ended up with a decimal answer, but that's okay. So for the decimals, let's say we're going to multiply negative 2.2 times 40. Let's go with negative 40. Okay. So we're going to deal with the absolute values first. So if we forget about the decimal point for a minute, 22 times 40 is 880. Then we have one number behind the decimal in the problem. So we need to have one number after the decimal point in the answer. So we don't really need that 0, so let's just get rid of it, and we'll have 88 as our answer. Okay, then we have a negative times a negative. A negative times a negative is a positive. So I'm going to put the positive sign there, but of course it's always present. It just happens to be invisible most of the time. So that's multiplying with decimals. So let me change pen color here, and we'll do a division problem. So with decimals, let's say we're going to have negative 4.5 divided by 0.3. Okay, so I think probably most of you would set this up inside the little box, and of course you would do top in the box, but I'm not going to do that because there's a shortcut way to do this. The 0.3 would be the divisor, and I'd have to move the decimal point over one place to the right, so I'm going to do that. So if I do that in that number, I'm going to do the same thing in the numerator, which would be the dividend, the number inside the box. And so I'm really just dividing negative 45 by 3. So 45 divided by 3 is 15, and a negative divided by a positive is a negative, and the decimal point is supposed to be at the end of the number because 45 divided by 3 is 15, so negative 15 is our answer. Okay, let's say we have some rational numbers like a fraction. I'm not going to do 2 examples, I'll just do 1. We'll do a division example. So how about, let's put it, okay, negative 1 4/5 times, let's go with 3 1/3. Actually, let's go with 3 1/10. Okay, so this is just like any other mixed number multiplication problem. We pretend like the negative sign isn't there, and we're going to do 9/5. Oh, I said we were going to do division. Oh, well, too late now. Yeah, no, we're going to change it to division. Let me just erase that. Oh my goodness, I erased the whole problem. That's okay. Negative 1 1/5. I'm just going to change the problem. Sorry about that. Divided by 3, and let's go with 3/10. Okay, so now we're back to the right thing. So we have to change this into an improper fraction, so that becomes 6/5. 1 times 5 is 5 plus 1. We're going to change division into multiplication. Our denominator is now going to become our numerator because we have to use the reciprocal. And 10 times 3 is 30, plus 3 is 33, so 33 will be our new denominator. And we still have a negative sign, so I'm going to put it there so I don't forget in the end. Okay, so now we do the multiplication just like we learned before. So we're going to cancel the 5 and the 10. And we can also cancel the 6 and the 33. Divide those both by 3. Divide 33 by 3, get 11. And so 2 times 2 is 4. 1 times 11 is 11. And since I have a negative times a positive, my answer is going to be negative. Okay, really quickly, let's look at this opposite of a number thing. So say we have something that looks like this. A negative sign in front of negative 41. Okay. So this is actually asking us to find the opposite of negative 41. It's just like when you did subtraction and you had to change subtract to add the opposite. These two negatives here end up making this positive 41. Okay, so let's talk about powers now. I only have a few minutes left in this video. So the most important thing for you to remember is that the exponent only applies what's immediately to its left. So you can read what all of this says right here, but I'm going to go straight to an example so that you can see how it all pans out. So let's say we have negative 2 in parentheses to the 6th power. So negative 2 to the 6th power means that we're going to take whatever is in parentheses, because that's what's immediately to the left of the exponent. Right here, immediately to the left is that parenthesis. They come in pairs. That means we're going to take whatever's in parentheses and multiply it by itself 6 times. So I'm going to have 6 sets of parentheses. It's going to take me longer to draw these than it is for me to actually explain the idea here. Okay. And then, of course, inside of there's a -2 for each thing. -2, -2, -2, -2, and so on. And so if I multiply these using my rule, I'm going to do, oops, that's a negative. I'm going to do 2 times 2 is 4. And that's going to be a positive because these two make a positive. Oop, I should probably use a different color. These two make a positive. Okay. And these two multiply together. 2 negatives make a positive. And these two make a positive because 2 negatives make a positive. So you see, because I have an even number of negative signs, my answer is going to be positive. And then 2 times 4 is 2, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Okay. This is different from if I were doing -2 without the power, without the parentheses, to the 6th power. Because now, once again, that negative sign only applies to what's immediately to the left. I don't have parentheses anymore. So what that exponent actually applies to is only the 2. So that means if I'm doing 2 to the 6th power, I'm just doing 2 times 2 times 2 times 2 times 2 times 2. Just doing that, so that's 64. And this negative sign right here, that negative sign is simply left over. So it has to go right there in front of that 64. Okay, now basically, let's go back to this slide that we had before. Okay, this is the kind of example I did before. There were no parentheses in it. I want you to notice right here what I wrote. If there aren't any parentheses, the answer is always negative. It makes absolutely no difference what the power is, because that negative sign that's right there is not included with the power. On the other hand, when there are parentheses, the number of negative signs, which is going to be the same as the exponent, is going to determine the sign of my answer. So, since I would have 4 negative signs, they're going to pair up by 2, so that's an even number. The even numbers are all going to cancel each other out. So, when the exponent is even, the answer is positive. But if the exponent is odd, the answer is negative. So sometimes in this case, the answer would be negative. So let's go back over here and I'll show you why that happens. So let's say we have -3 to the 3rd power in parentheses. So I'd be doing -3 times -3 times -3. So if I pair up my exponents, or my negative signs, if I pair up my negative signs, I'm going to have these two pair up, but I'm going to have this one left over. Okay? So this ends up being -27, because 3 times 3 times 3 is 27, and then I end up with -27 because of that leftover negative sign. The last thing I want to say to you about powers is, if you're doing a problem that has multiple operations in it, be sure you follow order of operations. Do everything in the correct order. Remember that exponents come before multiply, divide, add, subtract. So you follow the rule for exponents. It comes before add, subtract, multiply, and divide. Good luck.